I'm Joshua Hartshorn from Boston College, and today I want to talk to you about an important method for studying how babies learn language, which is the human simulation paradigm. This is a baby. Now, the thing about babies is they have a lot to learn, and since eventually they become adults who know a lot of stuff, hopefully, we know they must be learning a lot. Well, she probably just learned something. What we'd like to know is what, in fact, they're learning, how they learn it. It'd be really nice to, for instance, just be able to ask, okay, you just saw some stuff. What do you know now that you didn't know before? Unfortunately, it's really hard to get this information out of a baby. Right, Natalie, you see this? This is a ball. It's a ball. You see? It's a ball. It's a ball. Okay, Natalie. What is a ball? Can you tell me what a ball is? So that was probably not the best method for studying what an infant knows or what they're learning. There are, of course, better methods, such as the high-amplitude sucking procedure or preferential looking, conditioned head turn. So all these methods have some significant limitations. For instance, take preferential looking. So this is where we show babies some videos or objects and see what they look at. So for instance, we might take this ball and say, ball, and hopefully she looks at the ball. Hey, Natalie, look at the ball. Well, let's suppose she did look at the ball, and that would tell us that she knows something about balls and knows that this is a ball in some sense, but doesn't give us a lot of information. Does she think balls are always round? Does she think that balls have to be made out of rubber? Does she think balls come in particular colors, or they can be any color? I don't know, we could do more trials, so, show her balls of different colors or things that are not balls, that are, blocks that are not round, say ball, see if she looks at them. But that requires an enormous amount of time to run those studies, and babies don't have a lot of attention span. So you can't usually do those studies very easily. Another option, instead of trying to study the baby at all, is to try to do basically a simulation of the baby. So maybe do a computer simulation. Put together some mathematical code that is supposed to work kind of like a baby. Present the simulation with the kinds of input that a baby actually gets, and see what the simulation learns, how quickly it learns, what kinds of biases it has along the way, and from that, try to learn something about babies. So that was a computer simulation. Lila Gleitman and her students at the University of Pennsylvania have used an alternative kind of simulation, which they call the human simulation paradigm. Basically, instead of trying to simulate a baby with a computer, they simulate a baby with a human, specifically an adult human. So the idea is that you take an adult and you present them with the kinds of learning challenges that a baby might face, and you see what they're able to learn in those situations. And of course, the nice thing about adults is that you can ask them much more interesting questions than what you can ask a baby. Or at least you can get an answer from those interesting questions in a way that you can't from a baby, and get a lot more insight into what their experience was like. Now, of course, we're studying adults, not babies, so we still don't know what a baby actually does in those situations or what they're thinking. We just know what a baby might be doing if they were exactly like an adult. Now, babies, it turns out, are not exactly like adults. But even though adults are not perfect facsimiles of babies, you don't actually need a simulation to be perfect in order for it to be useful. When we do medical research, we usually study animals first, so you try out medications and medical procedures on cats or mice. Nobody thinks that a mouse is exactly the same as a human, and the difference is certainly a lot larger than the difference between adults and babies. But a medication that works on a mouse has better chance than a medication that doesn't work on mice to also work on humans. And a learning strategy that works for adults may well work for babies. Certainly it gives us a strong hypothesis to start with, which we can then design follow-up studies to actually test babies themselves. Natalie here would like to learn some words, and it would help her a lot if she could figure out when I'm talking what I'm talking about. So for instance, she might guess right now that probably I'm talking about this green ball, and that one of the words that I'm using is probably the word that refers to this object, the green ball. So researchers have used the human simulation paradigm to determine whether you can, in fact, guess what somebody's talking about when you don't actually know any of the words that they're saying, and if so, under what circumstances. So in the following video, which comes from Julie Sedevi at Brown University, all the sound has been removed. You're going to watch it, and there's going to be a bell at one particular point in the video, and your job is to try to guess what word was being said at that time. So what did you think that word was? Personally, I thought it was head. Turns out it's hat, which is not quite right, but clearly the video has narrowed down the possibilities a great deal. Now let's watch the video again and try to guess a different word. So that was villager. Yeah, I didn't guess it either. And that's one of the things we learned from the human simulation paradigm. We often think about the input to a baby as the words that they hear, and words that they hear a lot should be easier to learn. But not necessarily, because it really depends a lot on the situation. Some situations are going to be very constraining, give you a good guess as to what the word might be about, and some you're just going to have no idea. One of the other things that we've learned is that certain kinds of words are a lot easier to learn than others. So for instance, nouns are a lot easier to guess than verbs, which are also easier than, say, prepositions. So the human simulation paradigm is also used to study syntactic bootstrapping. So in the following example, which comes from Dev at Berkeley, the experimenter in a few key places has, instead of saying a word, done this clapping motion, and your job is to try to guess what word it is that would go in each of those spots. I'm going to show you the video twice. Once with no sound at all, so you have no linguistic context, and once with the sound, which includes all the linguistic context, all the words, except for our target words that we're trying to guess. Okay, so that was pretty hard. Let's try it with sound.
No, don't it. This is very hot. This water could... You. This is my favorite cup, isn't it? Do you? Your cup? Do you water or juice? You've a lot of juice, actually. Let's some water. Okay. We to be careful when we're... Oh, no. Some water on the table. Let's the water up.
So probably this time around you have a good guess as to what a number of those words were. So that's the human simulation paradigm, and you can see how it can be used to investigate which kinds of words are harder or easier to learn, to determine what makes for a good context for word learning, to understand the dynamics of syntactic bootstrapping, and to, probably most important of all, get some intuition into what it is like to be a baby who is trying to learn language.